Hey guys, it's Kane here. In today's video, I'm going to show you how the loop structures work in C and in C++. Basically, the first loop that we're going to use in this course is called the while loop, and we're going to see how this works in an actual programming environment. Previously, we had seen loops in the Flowgorithm. We had seen that the loop structure is very similar to control structures, but instead of going into a true and false branch, as long as the condition is true, now it keeps repeating itself, hence why it is called a loop. And once this condition is no longer satisfied, then the loop will go into a false statement where it will actually leave the structure and continue the rest of the program. So let's see how this is going to work in an actual programming environment. So let's just write a program, write a C++ program that shows all numbers in between 1 and 10. So in order to write a program like this, you can technically write the necessary statements and then display 1, display 2, display 3, and so forth. And eventually you will reach to 10 and your job will be done. For a limited range such as 1 to 10, this is not a problem. You just write a couple of lines one after the other and eventually you list all numbers and you will be done. However, there are circumstances that this can be a wide range and it might not be very practical or possible for you to write within that range. For example, what if this was, instead of 1 and 10, it was 1 million? And then it will be very difficult for you to actually write every single number within that range. So this is why we have the loop structures. Instead of repeating the same statements, we actually define a condition for it, and then we say that until this condition is satisfied, you're going to keep doing this stuff, and at the end you will have an upper limit or a specific condition. When you reach to that, you will stop. So that is the core of all loop structures. So let's see how this is going to work. I'm going to put the include IOStream, which is our library that we are using in C++. And the namespace, instead of repeating the std, and put the main function. Gonna put return 0 here. Alternatively, you can put cinignore and get. These are optional, so it's up to you if you want to put them or not. Now that we come to the program, we're going to define a starting point, which is 1 in this case. So I'm going to say something like integer count equals to 1, which is the starting point of my program. I'm supposed to display all numbers in between 1 and 10. And once I come here, I'm going to define my structure. Now, instead of if, we're going to say while, which means as long as. In the program language, that when you use a while, it means as long as. So while the count is less than or equals to 10 means that as long as the count is less than or equals to 10. When you write this, you can go and create a open and close curly brackets, and within those statements it will indicate that this is the start of the loop and this is the end. So whatever you write in between will execute as long as this statement is true. Now, one of the major traps that students fall into is that they don't define an exit condition for the loop structure, hence they create something called infinite loop. Now, in some programming environments, an infinite loop can be a good thing, such as It could represent the time flow, or as long as the program is being used, and so forth. However, in this kind of situation where we write our programs in a very traditional manner, an infinite loop is a bad practice. You should always create an exit condition for the loops. As an example, if I try to type cout and put a \n and show the count value, this will always show me the count value as 1 because I never change the count value. As the count value is 1 and as 1 is always less than or equals to 10, you will create an infinite structure that actually never ends. So it will keep showing us 1 forever and ever. Until you stop the program, it will keep showing the 1 value. It is imperative to define the loop structures with an exit condition. So our exit condition here will be plus count. Now each time you show the count value, I will increase it by 1. Hence why when I increase the value, it will keep changing. So at first it is 1, 1 is less than or equals to 10, show the value, then increase it by 1. When I increase the value by 1, now it's going to be 2. And it goes here, checks the condition again. 2 is less than or equals to 10, show it, now increase it again. This time it's going to be 3. Then go up, 3 is less than or equals to 10, now it's going to show 3. And then increase 4, 5, 6, eventually it will reach to 10 and it will become 11. Now when it becomes 11, 11 is no longer less than or equals to 10. Hence the program will stop and exit the loop condition and finish the rest of it, and it will show you the output. So I'm going to put the count value here, and plus count will increase the count each time, and it is actually our exit from the loop structure. So when we actually run this program, now we're going to see that the count value will start from 1, go up to 10, and there you can stop it. Now all you have to do, if this value changes in between, let's say 1 and 100, you will actually change this to 100 and run the project. Now all the values in between that range will be displayed to you. So it will go from 1 to 100. There, I'll go a bit down to see it. Oops, yeah, it's there, 100. So 100, and if you go up, it will eventually reach to the start point, which is 1. So that is the core of the loop structure. When you define it, there is a start point, there is the loop structure itself, which means as long as the count is less than or equals to 10, it means as long as this loop structure is true, it will execute this, and eventually you have to change the value in here, and once that value is changed, it will keep updating the loop, and at some point it will reach to an exit position and it will show you the outcome. If you don't define this value, which is going to be your exit from the loop will go to forever and you will never get the output you would like to see. Now let's solve another question to understand this concept better. Create a C++ program that displays all even numbers in range. The program asks the user to enter an initial number and an upper limit number as whole numbers. Having done so, the program displays all even numbers within this range. So it is just a different version of what we have done in here. So in here the range was defined already between 1 and 100, but this time around the program asks us to basically define this by user entries. So your initial number and the upper limit number will be defined as whole numbers, which are integers, and these will be entered by the user itself. So let's get started. I'm just going to copy paste these lines here and put the rest of the program over there. And this time around, I'm gonna actually ask the user to enter these numbers to me. So I'm gonna say something like enter the initial number, which I'm gonna take it as initial, and I'm gonna ask the same thing, but this time enter the upper limit number. And this time around, I'm going to take it as upper limit. So to define them, we can say initial equals to 0, and upper limit is also equals to 0. I put 0 values because if the user doesn't enter anything valid or anything whatever that is not really acceptable, at least the loop structure wouldn't really try to crash or try, at least it wouldn't be affected from it. So when we come there, we need to define our while. So just as we did in the previous exercise, we're going to put the initial value here and put the uppercase value. So we're going to say something like, instead of count less than being 100, we're going to say the initial value is less than or equals to the upper limit. Now that we already defined this, we need to show all even numbers. Now you can make it like an if statement here, should you want to. There are multiple approaches. You can increase the initial number 2 by 2, but then you don't know if this number is an even or an odd number. So I would say the best way is here to make sure this number is going to be divided by 2 with a remainder or without. So we can say initial number divided by 2 is equals to 0, then display this number. So I'm going to display the initial number. If this is not true, then do nothing, because our program will not show the odd values, it will only show the even values. So we're going to come down there and say initial. So each time the initial number will be increased and eventually will reach to the upper limit. Now when you enter numbers, it will show that properly. Make sure to write this correctly. So my initial was not, and I'm going to run this. So whenever I enter two numbers, 2 to let's say 20, it will show me all even numbers within that range. 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So as you can see, it shows all numbers within range. A program like this, however, is very easy to crash. For example, when you go there and type 10 and then type 2, it might not understand what you are trying to do, and it shows you nothing. To counter this, you can simply put an if statement here, should you want to, and ask the user to enter the initial number lower than the upper limit. So we can put an if statement, should we want to, if the initial number is greater than or equals to the upper limit number, we can display an error message. Please enter the upper limit greater than the initial number. And only when this is correctly entered, you can actually do all this stuff. So you can add an else statement here, should you want to, and put the entire loop into the else statement. This is a good opportunity also to see how you can work around with different constructs to solve complex level problems. In here, as you can see, we did not only use the loop, but we use if else as well. So the actual programming gets difficult when you need to understand which programming construct fits into which situation. And the power of programming arises when you combine these programming constructs. So a loop by its own might not be very useful, but when you combine it with a selection statement and with control statements such as the one that we did, then you can create a smart program. Now when we execute this and we try to enter, let's say 9 and 2 here, then it will say please enter the upper limit greater than the initial number. So the program kind of like direct you to the correct path to enter the data properly. So when I enter the values as 1 and 9, as you can see this time around it works fine. Even though both values that I entered are not even numbers, the program displays me all even numbers within this range. So this is the core structure of the loops. So that's how the loops work in programming. You can combine them with selection, as you can see, to generate the outcome that you desire. Before ending this video, I'm going to show one more exercise from your lab sheet, which is the third lab sheet and the question 11. Let's read this question. Write a complete C++ program that gets 10 item prices from the user. The program will calculate the sum of these prices and show this on the screen as the output. And as you can see, there is a output, a sample run was given to us. So we need to get 10 item prices and we need to calculate the sum of these prices. So we can go into our program and create a new one. So I'm going to save this as prices or loop prices and copy paste some of the statements that I'm going to use, such as namespace main return 0. Now in a program like this, we already know that there are 10 prices. So I'm going to define integer each price as 0. You don't have to define a 0 because it's the input. And I'm going to define another one called sum of prices. Oops, this should be 0. You can also define total number of prices, which is indicated as 10, or you can just simply put this as just 10 inside the program. So it's up to you how you decide to put the 10 number in there. So what we're gonna do in here, so I'm gonna put an integer counter, initially 1, which will increase each time that the price is entered. I will increase the value of the counter. So now that I have the variables, I'm going to type the while statement and say while the counter is less than or equals to 10, enter the price. So I'm going to put \n, please enter the price of item, and I'm going to put this symbol here showing the number. So I'm going to put the number of the item, and when I come there, I'm going to put the counter itself. So the counter is first one, it starts at 1, so the first price that you enter is actually 1. And I'm going to put the tokens and leave some space for the user to enter the value. And each time a price is entered, I'm going to take it as each price. So now that this part is complete, we can run the program and see that each time the loop structure works, it will take an item from you. Before I run it, however, I must make sure that the counter value increases, or otherwise I'll fall into the trap of creating an infinite loop. So I can save it now and run it. This should be counter, the semicolon here, yes. So running it. So please enter the price for item 1. I'm gonna enter a price, let's say 50, and now it asks for 2. Now it's 3, now 4, now 5, and so forth. Because we haven't done the program, however, it will not show us the sum of prices. Before we are done from it, to finish the program, we have to put the sum of prices here and say plus equals to each price. So initially sum of prices was 0, and each time a price is added, it will add on the top of it. You can say something like sum of prices equals to the old value of sum of prices plus each price entered. So you use either this one or that one, whichever you prefer. So plus equals to means that you initialize the new sum of prices on the top of the old one, and you add the each price as well. So that is the actual meaning of plus equals to, or you can alternatively write it like that. One final thing before we finish the program is to show the total price. So I'm gonna say something like the total price equals to sum of prices. You can even put a currency should you want to, although this is not mentioned in the question. You can put the prices in terms of dollar or some other currency would you like to see on the screen. So I am going to run this. So enter the price of item 1, let's say 6, 7, 4, 3, so that's 20 now, 30, 45, 50, 60, 100, and 115. So that will be the price. So 10, 20, 30, 45, 50, 60, 70, 80, 95. Sorry, that's my bad. So it should be 95. So as you can see, the program actually does its job quite well, and you can test it up with fewer numbers if you like to see that. So you can make it like 3, for example, just by writing that. So it could be maybe easier for you to test it. So you can simply go there and run the program and just enter 3 prices, which you can easily calculate. And as you can see, it's much easier to calculate with instead of 10 numbers, you can just write 3 items here and calculate the price instantly. And if you expand this counter, you will reach to the outcome of calculating it according to the question. So this is where I'm gonna stop for this video. As you can see in this video, we have solved 3 different exercises with using loops. First, we described the concept of loop, how it works in the programming environment. Then we solved 2 questions different from one another, which one of them combined the selection structure with loops, and another one used the iterative statements to calculate the price. So this is the end of the while loop. I'll see you guys in the next video. Take care.